Okay, let me check if I'm live or not. Just a second. I think I'm live. Let me share my screen with you all. And the screen is visible to you all. So this is today's problem, trial of ones. Let me read the problem statement. Given an integer n, the task is to count the number of binary strings of length n, number of binary strings of length n that contains at least one pair of consecutive ones. That contains at least one pair of consecutive ones. Okay, a binary string is sequence made up of only zeros and ones. Yeah, I know that. uh, n is equal to 2, output is equal to 1. There are 4 strings of length, consecutive ones. N is equal to 2 means length 2. Right, length 2. Okay, let me read it again. At least one pair of consecutive ones. At least one pair of consecutive ones. In this, uh, in this, I have only one pair, one one. Okay. In this, I have 0 1 1, 1 1 0, and 1 1 1. Okay. For 5, I will have more than 18, like 19 strings, right? Okay. Uh, if we'll do like suppose if I'll have a integer, okay, uh, 6 or 7 or 2, let's suppose. If I'll start from the very last index and count, or suppose uh, for any zero, any number, okay, for any of the number, how many zeros are there, how many ones are there, and if the ones are consecutive, that is of our use, right? We have to iterate through all the elements, okay, and the value of n, for n, how many consecutive ones are there? For like for 3, how many consecutive ones are there? 3. For 2, there are uh, 2 of them. For 3, there is also 110. For 3, there is 2 of them. For 2, there is 1. For 1, it is not countable. Okay, so can we do something like we'll start from the very last index, like from n, and uh, okay, can we do something like if the present current bit is 0, okay, the current bit is 0, uh, the next bit can be 0 or 1, I don't care. But if the present current bit is 1, the next bits, which is going to be something something, I can place in any order. I got a pair, I can say that. But how we are going to implement that? Because we have to keep track of all the elements, right? Okay, let's think again. uh, Keeping track of, okay, not current, I have to keep track of the previous one or previous 0, like the last one, last index element was 0, The last element index was 1. I have to keep track of that. Okay. Uh, if the previous one is 0, like the current element can be 0, can be 1, I don't care. But if it is 1, I have to strictly put 1 right now. Okay. And if we are going to place 0, it is not going to work. Like, it is not of our any use. Okay. But the main thing is how I'm going to uh, show it into an answer. How I'm going to think that. Okay, let's first of all start with a brute force solution before moving further. What can I do? I can simply try placing 1 or 0 at the current position. I can put this 1 or 0 and count. Put 1, 0 or count. Okay, that's what I can do. So for that, uh, let me just think. Write the brute force solution. Okay, great. So the brute force approach is going to be and helper. uh, Here I'm going to pass yeah, here I'm going to pass few parameters, which is going to be in which index we are, what is the previous index, in which index we are, what is the previous index, which is going to be 0, what is the length of the string. Great. And we are going to return answer. Int answer is equal to this helper. Great. Now int helper int helper and current int previous int that. Okay, what I'm going to do, first of all, if the previous is 0, I just have to increment like have to increment the current by 1 and check by placing 1 and check by placing 0. Okay, if previous is equal to 0, check by placing 1, check by placing 0, answer is equal to helper current plus 1 comma, in place of previous I'll first of all keep 0 plus place 1 and n. Great. Now what if the previous is not 0, previous is just 1, then what? uh, okay, then what? Then I have to, if the previous is 1, there is no use of putting 0. But what if the answer by putting 0 at that place is greater? So yeah, I can do something like else answer is equal to helper of current plus 1 comma 0 comma n. Yeah, I can do this. And after putting 0, whatever I came up with, I'll update it with I'm going to put 1 now. Okay, so the what is going to be the remaining places? one here, and see, I got two consecutive ones, so I don't care about the next consecutive places, which is going to be n minus the current index. So yeah, answer plus answer plus one left shift n minus current. Yeah, okay. If this is going to be, if the last index is 1, this is going to be our case. The last one is 0, this is going to be our case. Great. What is going to be the base condition if the current is simply greater than the value of n? If current is greater than n, return 0, and answer is equal to, I'm not adding the answer, I'm first of all doing this. So answer, so yeah, let's see if this, okay, I have to return the value of answer also. Great. Let's see if this works or not. It is working fine for now. Yeah, it should work for few test cases, not all of them. Yeah, I think, okay, great. It passed all the test cases. Great. So 30. Okay, great. See, I can optimize it using DP, because we are calling again and again for like for the same consecutive ones. We can optimize it using DP, but I don't think there is any like need to do that. But let's do it again. Like let's optimize it using DP. Okay. So what else I'm having? I am recursively checking and constructing all the binary strings of length n. Okay, of length n. I'm checking that the previous bit is 1 or 0. Okay, if the previous bit is 1, I'm updating it with another one, like I'm keeping another one, uh, like, and updating one means I'm just adding it with, like, doing left shift of n minus I. Okay. uh, okay, okay, so okay, one thing, no, that is not going to work. uh, that is for sure, but how I'm going to show it in using DP? uh, I am doing left shift for the remaining. Acha, for the remaining part, can I do 2 into 2 to the power n minus I? Because rather than doing one left shift, I can do 2 to the power n minus I. It is because it will handle all the combinations that is going to happen between them. Yeah, I can do that. Great. First of all, constructing a DP. Again, write this code. Vector of int comma and DP. Okay. Now, what is going to be the size? N minus 2 comma vector of int of 2 comma minus 1, because I'm checking the last element as 0 or 1. Great. Now helper function, and int answer is equal to helper. uh, Last time I was passing three things, right? Current, previous, and this time I'll have to pass one more thing: current, previous, n, and dp. Great. Now I'm going to update it, right? So it is going to be, and okay, everything is going to be okay. Why I have removed that? Let me see if I have that or not. Why have I even removed it? This one. Okay, it is going to be the same. Just I have to do some add some dp part if dp of current and previous, if this is not equal to -1, this is the case, return 0 or return this dp of, sorry, dp of current and previous, answer is equal to 0. Do the same thing again and again, call the same thing, also pass here dp comma dp comma dp comma dp, sorry, here put dp of current previous is equal to this, dp of current and previous is equal to our answer. I think this should work. Okay, no, and plus 2 if current is greater than dp of previous current is not equal to this, dp of current and previous, answer is equal to 0, previous is equal to 0, uh, just answer is equal to helper of 0 and helper of 1, else current plus 1. Okay, one thing I have to do this. N minus current. dp of current and previous is going to be our answer, right? dp on dp of current and this is going to be our answer. What I'm doing is answer is equal to answer plus is equal. I have to add these two sums, right? If previous is equal to 0, answer is equal to current plus 1, 0, this. Okay, else answer is equal to helper of 0 plus I can move it here plus this thing. Right, TPF content previous. This is equal to answer. Current is greater than N. Plus 2 to comma minus 1. Helper of 1 this. Acha. I'm not even returning answer, bro. Yeah, this should work. Yeah, it passed all the test cases. So it is top down DP. If I want to implement bottom up, I can do that also, but let's not do that. It's simple. Okay, great. So thank you so much for watching.